Welcome to TechCast by Raqmedia.com, your quick stop for the latest tech news, smart hacks, and cutting-edge updates. Stay informed, stay ahead. Let's dive in.
Welcome back to Raqmedia TechCast, Episode 9, your one daily stop for the latest tech news and trends.
Episode 9 already.
Yeah, time flies when you're having fun, right?
Absolutely.
So today we're diving deep into something truly groundbreaking. Microsoft's foray into topological quantum computing.
Oh, this is going to be good.
We've got a mix of Microsoft announcements, scientific articles, and even a YouTube explainer video from Domain of Science to help us break down this complex topic.
I love their videos.
Yeah, me too. They make even the most complicated subjects seem understandable.
Yeah, and what's fascinating about this is Microsoft isn't just trying to build like a slightly better quantum computer.
Right.
They're aiming to revolutionize the field with a whole new type of quantum bit.
Okay, so before we get into the nitty-gritty of Microsoft's approach, can you give us a quick overview of why everyone is so excited about quantum computing in the first place?
Sure.
What's the big deal?
The big deal is that quantum computers have the potential to solve problems that would take classical computers, even the most powerful supercomputers, like billions of years.
Wow, billions.
Yeah, it's because they operate on the principles of quantum mechanics, which allows them to perform calculations in ways that classical computers just can't.
So it's not just about speed, it's about a whole different way of approaching problems.
Exactly, and one of the areas where quantum computers are expected to excel is in simulating quantum mechanics itself.
Okay.
This opens up incredible possibilities for fields like materials, science, chemistry, and drug discovery.
So, give me an example.
Like, imagine being able to design new materials from scratch, atom by atom.
Wow.
Or simulate complex chemical reactions to develop life-saving drugs.
That's mind-blowing.
Yeah, it is.
That's where Microsoft's unconventional approach comes in this thing called topological quantum computing.
Ah, yes, topological quantum computing.
What makes it so different?
Well, the basic building block of any quantum computer is the qubit, which is like the quantum version of a bit in a classical computer.
Right.
But qubits are notoriously fragile and susceptible to noise.
Hold on. By noise, we're not talking about loud sounds, right?
No, not at all.
Okay, good. Because I was picturing like a construction site next to a quantum computer.
Right. In quantum computing, noise refers to any kind of environmental disturbance that can mess up the delicate state of a qubit and cause errors.
I see.
It's one of the biggest challenges in building practical quantum computers.
So how do topological qubits address this noise problem?
That's a good question.
I remember the Domain of Science video used a really interesting analogy with mugs and donuts.
Yes, that's a classic way to illustrate the concept of topology, which is a branch of mathematics that deals with the properties of objects that remain unchanged even when the object is deformed.
So a mug and a donut are topologically the same because they both have one hole, even if you stretch or squeeze them.
Precisely, and that's the key idea behind topological qubits. The information is encoded in a topological property which is inherently resistant to noise.
I'm trying to picture this.
It's like writing a message on a Mobius strip.
Okay.
No matter how you twist it, the message remains intact.
Okay. So instead of building qubits that are easily disturbed by noise, Microsoft is trying to build qubits that are inherently noise resistant because of their topological properties.
Exactly. They're using something called Majorana particles or Majorana zero modes to create these topological qubits.
Majorana particles, that sounds pretty exotic.
They are, but they're not fundamental particles like electrons or protons.
Okay.
They're actually quasi-particles, which are emergent phenomena that arise from the collective behavior of electrons in a specifically engineered material.
Quasi-particles, so not a single particle, but a kind of collective behavior that acts like a particle.
Exactly. It's kind of like a wave in water.
Okay.
The wave itself isn't a separate water particle, but rather a pattern that emerges from the movement of many water molecules. Similarly, a quasi-particle is a pattern of behavior that emerges from the interactions of many electrons.
So to create these Majorana particles, Microsoft had to figure out how to engineer a material that would exhibit this specific collective electron behavior.
Yes, and that's no easy feat.
Yeah, I bet.
It requires developing entirely new materials and fabrication techniques.
Wow.
They literally have to arrange atoms with atomic precision.
Like atomic Legos.
Right, to achieve the necessary purity and structure for these Majorana particles to emerge.
Wow, talk about pushing the boundaries of material science.
Yeah.
So has Microsoft actually been able to create these Majorana-based qubits?
They have, and they've recently achieved a significant breakthrough.
Oh.
They successfully created and measured the parity of a topological qubit using Majorana particles.
Parity, does that mean even or odd, like an even or odd number of something?
You got it.
Okay.
In this case, it refers to whether there's an even or odd number of electrons on an island within the nanowire that makes up the qubit. Measuring this parity tells you the state of the qubit, whether it's a 0 or a 1.
So being able to reliably measure the parity of a Majorana-based qubit means they can actually determine the state of the qubit. That's huge.
It is.
It's a critical step towards building a functional quantum computer using these exotic particles.
It absolutely is. And this breakthrough has led to another exciting development, the Majorana 1 chip.
Majorana 1, it definitely has a ring to it. Tell me more about this chip.
It's the world's first quantum chip powered by Microsoft's new topological core architecture. It leverages what they call a topoconductor.
Okay, I have to ask, what in the world is a topoconductor?
It's another groundbreaking material they've developed. Think of it as a special type of material that allows them to observe and control those Majorana particles to create more stable and scalable qubits. And that scalability is one of the most exciting aspects of Microsoft's approach.
Scalability in what sense?
Well, Microsoft claims that their architecture offers a clear path to 1 million qubits on a single chip.
1 million qubits. That's just mind-boggling. How does that compare to what other companies are doing?
Current quantum computers have only a few hundred qubits at most.
Right.
So 1 million qubits would be a massive leap forward.
Yeah, for sure.
It's that potential for scalability that makes Microsoft's approach so compelling.
This is all incredibly fascinating, but I have to admit, it's a lot to wrap my head around.
I know, right?
And we haven't even touched on what we could actually do with a 1 million qubit quantum computer.
It's true. We've just scratched the surface of what's possible.
Before we jump into those potential applications, for those of you listening who want to explore more cutting-edge tech, be sure to check out Raqmedia.com.
It's an awesome resource.
We've got a ton of deep dives into all sorts of fascinating topics.
It's a great resource for anyone who wants to stay ahead of the curve.
Now let's get back to this 1 million qubit future. What kind of world could these incredibly powerful quantum computers create? What problems could they solve that are just impossible for our current computers?
The potential applications are truly mind-boggling. We're talking about revolutionizing entire industries, from medicine to materials, science to energy.
Give me some examples. What are some specific problems that a 1 million qubit quantum computer could tackle?
Well, imagine a world where we could design self-healing materials.
Self-healing materials like something out of a sci-fi movie.
Exactly. Think about it. A scratch on your phone could literally repair itself. Bridges and buildings could become much safer and more resilient. Even our clothes could repair themselves.
That sounds incredible, but how would that even work?
Quantum computers could allow us to design materials at the atomic level, creating structures that are inherently more robust and adaptable. These materials could be programmed to respond to damage by reorganizing their molecular structure, essentially healing themselves.
So it's not just about making stronger materials, it's about making materials that can adapt and respond to their environment.
Precisely, and the implications go far beyond just consumer products. Think about the potential impact on infrastructure, transportation, and even space exploration.
That's just one example. What else could these super powerful quantum computers do?
Let's talk about the environment. Quantum computers could help us develop completely new ways to break down pollutants, like microplastics that are plaguing our oceans and ecosystems.
So we're talking about solutions to some of the most pressing problems facing our planet.
Absolutely. They could help us design more efficient solar panels, develop new catalysts for carbon capture, and even create fertilizers that don't harm the environment.
It sounds like quantum computing could play a key role in creating a more sustainable future.
It certainly has that potential, and let's not forget about healthcare.
Of course, I'm eager to hear how quantum computing could revolutionize medicine.
Imagine being able to design drugs with pinpoint accuracy, targeting specific diseases at the molecular level. With minimal side effects, quantum computers could simulate the complex interactions between drugs and the human body, leading to a new era of personalized medicine.
So we're not just talking about treating diseases. We're talking about potentially preventing them altogether by understanding how they work at the most fundamental level.
Exactly, and quantum computers could help us unlock the secrets of the human brain, leading to breakthroughs in the treatment of neurological disorders like Alzheimer's and Parkinson's.
It's incredible to think about the possibilities, but Wouldn't all this require a massive leap forward in our understanding of biology, chemistry, and physics?
It would, but that's part of what makes this so exciting. The development of quantum computers is driving a renaissance in scientific discovery. As we build more powerful quantum computers, we're going to need a deeper understanding of the fundamental laws of nature to harness their full potential.
It's almost like a virtuous cycle. Quantum computing pushes the boundaries of science, and scientific discovery, in turn, pushes the boundaries of quantum computing.
Exactly, and who knows what other amazing applications we'll discover along the way.
Okay, so let's say I'm completely captivated by this whole quantum computing thing. How can I learn? Are there any resources out there for someone who's not a quantum physicist?
Actually, Microsoft has a fantastic tool called Azure Quantum with Copilot. It's a free educational platform where you can explore interactive lessons program, quantum computers using software emulators, and even get your questions answered by an AI assistant called Copilot.
So even if I don't have a PhD in physics, I can still dip my toes into the world of quantum computing.
Absolutely. It's a great way to get a feel for how quantum computers work and what they're capable of.
Speaking of exploring and learning more, don't forget to check out Raqmedia.com for more in-depth explorations of cutting-edge technologies.
It's a treasure trove of information for anyone curious about the future of technology.
Now, while the potential benefits of quantum computing are undeniable, it's also important to acknowledge that this technology raises some important questions.
Yes, of course. Like any powerful technology, quantum computing needs to be developed responsibly. And ethically, we need to consider the potential implications for privacy, security, and even the future of work.
So it's not just about the science and engineering, it's also about the societal impact and ensuring that this technology is used for good.
Absolutely. It's crucial that we have open and honest conversations about the ethical implications of quantum computing and develop frameworks to guide its development and deployment.
So this isn't just a technological revolution, it's also a societal one. We need to be prepared for the profound changes that quantum computing could bring.
I couldn't agree more. We need to be proactive in addressing the potential challenges and ensuring that this technology benefits all of humanity.
It's definitely a lot to think about, but the future is full of possibilities, and I, for one, am excited to see what the quantum era holds. It's clear that quantum computing has the potential to reshape our world in ways we can barely imagine, but it's also a journey into the unknown, and there are sure to be challenges and surprises along the way.
Absolutely. It's a field that's constantly pushing the boundaries of science and engineering. Just when we think we've grasped the basics, something new emerges that shifts our understanding.
As we wrap up this deep dive into Microsoft's pursuit of topological quantum computing, what are some of the key things you think our listeners should be paying attention to in the coming years? What are the big milestones or breakthroughs that could signal a major shift in the field?
Well, one of the key things to watch for is the development of fault-tolerant quantum computers.
Fault-tolerant? What does that mean in the context of quantum computing?
It means building quantum computers that can perform reliable calculations, even when individual qubits are prone to errors. Remember how sensitive qubits are to noise?
Right.
Even with topological protection, there's still a chance that errors can creep in.
So fault-tolerant quantum computing is about building systems that can correct those errors and produce accurate results, even if some of the qubits aren't behaving perfectly.
Exactly. It's a bit like having a safety net for your computations. Building fault-tolerant quantum computers is a major engineering challenge, but it's essential for unlocking the true power of this technology.
So keep an eye out for any news or announcements related to fault tolerance. What else should we be watching for?
Another big milestone will be the demonstration of quantum advantage. This is the point at which a quantum computer can solve a practical problem significantly faster or more efficiently than a classical computer.
So that's the moment when quantum computing goes from being a theoretical possibility to a practical reality.
Exactly. And it's not just about speed, it's about solving problems that are simply impossible for classical computers, no matter how powerful they are.
So achieving quantum advantage would be a major turning point, signaling that the quantum era has truly arrived. What are some of the early applications that we might see once we hit that milestone?
Well, some of the most promising early applications are likely to be in areas like materials, science, drug discovery, and cryptography.
We've already talked about materials, science, drug discovery, but how could quantum computers revolutionize cryptography?
Quantum computers pose a potential threat to our current encryption methods, which rely on the difficulty of factoring large numbers, but they can also be used to create entirely new, unbreakable encryption methods.
So it's a double-edged sword. Quantum computers could both break our existing security systems and create new ones that are virtually impenetrable.
Exactly. That's why the field of quantum cryptography is so important. It's about staying ahead of the curve and ensuring that our data remains secure in the quantum era.
It sounds like there's a lot of work to be done, both in terms of developing the technology and in thinking through its implications for society.
Absolutely. Quantum computing is still in its early stages, and we're only beginning to understand its full potential. But it's a field that's moving incredibly fast, and the next few years are going to be incredibly exciting.
So the future of quantum computing is full of possibilities and challenges. And while it's impossible to predict exactly what the future holds, it's clear that this technology has the potential to transform our world in profound ways.
I agree. It's a journey into the unknown, but it's a journey that I'm excited to be a part of.
Before we wrap up, I want to remind everyone to visit Raqmedia.com for more fascinating deep dives into the latest tech trends.
You'll find a wealth of information on everything from artificial intelligence to blockchain to the metaverse. It's the perfect place to stay informed and engaged with the ever-evolving world of technology.
Well, that's it for today's deep dive into the world of topological quantum computing and Microsoft's ambitious quest to build a new kind of quantum computer.
It's been a pleasure exploring this fascinating topic with you.
A huge thank you to all our listeners for tuning in to the Raqmedia TechCast, your one daily stop for the latest tech news and trends.
And a special shout out to our brilliant scriptwriter, Ezzedine Yahawi, for crafting such a thought-provoking episode.
Don't forget to subscribe on Spotify so you never miss an episode. Until next time, stay curious and keep exploring the world of tech.